Alright, for this video we're going to look at quadratic equations and we're going to graph them in a different form. We worked on vertex form before and now we're going to work in a form that's called standard form. So we're going to plug in our values and get our parabola, and then we're going to identify some key features and parts of the quadratic graph. So I've got an equation here and we're going to use the tables and plug in these values of x into the equations and then see what comes out, and then we'll list them as coordinates that we can plot and have a graph for our coordinate plane. So the first number is saying replace all of the x's with -2. So I'm going to write inside of parentheses -2 to replace all of the x's. So notice I just replaced the x's with -2, and now I can put that on my calculator. -2 squared minus 2 times -2 minus 3. And out comes 5. So a -2 comes out in, 5 comes out. So the coordinate is -2 comma 5. My input that matches with my output is -2 comma 5. Alright, let's keep going. Plugging in -1 now instead of -2 for all of the x's. Same process. And I get 0. So my coordinate would be -1 comma 0. Plugging in 0, out comes -3. So it's 0 comma -3. Plugging in 1, -4 comes out. Now I'm going to plug in 2. And -3 comes out. So I'm starting to see that parabola shape develop just by the points I'm getting, because here I'm hitting -3 again. So my coordinate was -2, -3. So I'm guessing my coordinate here should be 0, but let's check and make sure. If you plug in 3, you got 3 squared minus 2 times 3 minus 3, and I get 0. So that's what I was expecting. And then also, I'm expecting 5 right here. Let's see if that happens. Plugging in 4 into this equation. And out comes 5. Alright, so we can plot those points. So I've got -2 comma 5. So 2 to the left, up 5. -1, 0. So I'm right on the x-axis. 0, -3 is right on the y-axis. 1, -4. 2, -3. 3, 0. And 4, comma 5. And then now you see your nice parabola shape. Alright, so before what we worked on was we identified how we could shift this parabola up and down, left and right, side to side, and flipping it over or reflecting it over the x-axis. Today we're going to focus on a couple different points that are important and are key features of a quadratic equation. Before we do that though, I just want to remind you that you could have done all this work on your calculator. I wanted to show you by hand. But if you hit y equals, and you clear out what's ever in that screen, and you type in your equation, and hit graph, you should see a graph that's similar to the one that we have. And then also to get that table, you hit second table, and now you can see the same coordinates that we calculated. So I wanted you to understand where these numbers are coming from and how to calculate them without a calculator or without using the table function on your calculator. Alright, first question asks, the shape that the graph takes is called a parabola. Remember, that's a special word for our equations that are quadratics. They have a parabolic shape. It's a parabola. It's a U-shaped. Some new points that we're going to focus on where the graph crosses the x-axis are called intercepts. Or actually, we'll call these roots. They're x-intercepts or roots. So the x-intercepts in this graph are right where it crosses on the x-axis. So there's two of them. This is an x-intercept, and this is an x-intercept, because you're crossing on the x-axis. Make sure my x's are very clear. Okay. The turning point of the parabola is called the vertex. We've seen this before, and we've kind of dealt with it already. The turning point means when you're on your graph, at what point does it change direction and start heading the other way? So here I am on the graph, I'm going down, my y values are going negative, but then I get to this point and all of a sudden I start going positive. So this is called your turning point or your vertex. We used other terms last week like minimum and maximum, and in this case this is the minimum. So the vertex is the same thing as the minimum or the maximum of a graph. So in this example, the turning point is located at, and we can list it at 1, -4. Looking at the table, you can see that this is the lowest value that the y values go to. So that's why it's a minimum. This is as small as the y values go, and then they increase from there. Another piece of quadratic equations is called the axis of symmetry. What that means is that if I draw a line through the vertex, so a horizontal or a vertical line, I'm going to draw it dotted here. This line that goes through the vertex cuts the graph in half, so I can flip over the right-hand side onto the left-hand side or vice versa. So this is called your axis of symmetry, and what it does is it tells you the amount of spaces away that the points are on the graph from either side of the line. So notice that these are on the same y value, they're just 3 spaces away from the axis of symmetry on either side. So the equation of the axis of symmetry is just whatever your x value is through this vertex. So the x value of your vertex here is 1. So x equals 1. And then the last piece that's new that we'll talk about is the y-intercept. The y-intercept is just like the x-intercept, except it's asking where does it cross at the y-axis. So the y-intercept here in this problem is located at 0, -3. The y-intercept is always when x is 0 and then y is the value on the y-axis. The x-intercepts are the flip. It's you have values for the x's and then the y is 0. So the two x-intercepts, let's write them down up here, are at -1, 0 and 3, 0. These play important parts in later lessons that we'll work on, so it's important that we understand where they are and how to identify them, because we'll use them when we solve equations that involve quadratics. Alright, so now you've done that, let's try the stations and try graphing and identifying some of these key features.